Yes, good day to you all. You are welcome to Physics 10 class once again. This is our second experiment for the semester. By God's grace, we will be taking determination of the relationship between power dissipated and the resistance of a circuit using a variable power supply. So we'll be introducing ourselves to the topic, that is introduction, objective of the experiment, the apparatus, the method or the procedure to follow to achieve the objective of the experiment, the data or result presentation, that is how to present your result after performing the experiment, your graph, your slope, and precautions for the experiment. So we move on to the introduction. So I'll be putting up through a particular keyword in the experiment in the topic, which is power dissipation. It says power dissipation is a process by which an electronic or electrical device produces heat as an undesirable derivative of its primary action. During this process, electrical power is converted into heat energy. Now, what this means in simple terms is that when an electrical device or an electronics or electrical device is working, let's say the device, for example, a bulb, our fan at home, our computer, our mobile phone, when any of these devices is working, it releases some energy as heat, and this release of energy happens as a result of the work it is doing. Our main purpose of our mobile phone is not to release energy, but because of the work our mobile phone does, we receive messages, we receive phone calls, we make phone calls, we chat, we do all sorts of things on our phones. Because of the type of work all this our mobile phone does, because of the work our computer does, because of the work our fan does, there is a release of energy by these devices. So the energy that is being released, it is being released as heat. And this release of energy happens because of the work these devices are doing. So, and that particular heat is what we call power dissipation. Power dissipation occurs naturally in resistors, which are important components of an electrical circuit. We know that a resistor slows down electricity, or let's say regulates the amount of current. But if you look at our capacitor and our inductor, their own work is to store energy. They do not do with regulation or limiting of current. So because of the type of work, the type of function that a resistor does, power dissipation occurs naturally in resistors because of the important component that a resistor is. Each resistor comes with a power rating, which signifies the maximum amount of power it can dissipate without being damaged or burned out. It's just like you having a cup. There is the particular amount of water you can put in any cup that will fill it. The moment you put more than what that cup can take, it will spill. So the same thing happens to resistor. That is why every resistor has its own power rating. The moment you are having more than what that resistor can take, the power rating is just like the limit is just telling us the limit by that our resistor can take, how much heat or how much power that it can handle. The moment you are giving it more than that amount of heat or power that it can handle, then you will be at risk of damaging that resistor due to overheat. So this type of overheating can damage and can burn the resistor. So each resistor comes with a power rating, which signifies the amount of power it can dissipate
without being damaged or burned out. The power dissipated in a resistor can be calculated using the formula P equals to V multiplied by I. P, we say that power dissipation equals to V I, where V represents the voltage and I represent the current. However, since V equals to IR, remember our Ohm's law, since V equals IR according to Ohm's law, so we can decide to substitute V as IR in our P equals to VI. So instead of writing P equals to VI, you can decide to replace that the V in VI with IR. So you now have IR, you will now have rather P equals to IR times I. Remember, you're having two i's now, that is I square. So our formula, instead of having P equals to VI, we can also have P equals to I square R. Can you see? So we can actually get this particular formula from equation 1, from the first formula. Likewise, we can as well get another formula if we decide to substitute V equals to IR, I equals to V over R. So since we know that from Ohm's law, our V is IR and our I is V over R. So I can decide to substitute for I. Instead of saying P equals to VI, I can say P equals V multiplied by V over R. So I will now be having another equation again. So which means for power dissipation, there are three formulas that we can make use of depending on what we are given in our question, depending on what we are trying to get, depending on the parameter we are asked to look for. Depending on the parameter we are asked to look for. So equation 3 is gotten after substituting equation 2 into equation 1 above, and this shows that power is directly proportional to resistance and keeping I as constant. Therefore, note that when power increases, the resistance will also increase. That is from equation 3 now. When power increases, the resistance will also increase. Remember, it is in equation 3 that we are having our resistance. Then the second one says when resistance decreases, from that particular equation 3, when resistance decreases, power also reduces, keeping current constant. This happens because they are proportional, directly proportional. When they are directly proportional, it means whatever happens to power dissipation, the same thing will happen to the one at the other side, which is the resistance. So if power dissipation is increasing, the resistance will increase. If it is reducing, the resistance will also reduce. Now, the objective of the experiment says to investigate the relationship between the power dissipated in a filament lamp. So in this case now, the particular electrical device we will be working with is our filament lamp. Filament lamp is just like our bulb. So a filament lamp and resistance of the lamp, to investigate the relationship between the power dissipated in a filament lamp and the resistance of that particular lamp. The apparatus needed will be needing a voltmeter that measures our voltage, an ammeter that measures the current. The filament lamp itself will be needing a key. A key is just like a switch. By the time in circuit diagram, the key, when the key is closed, it means the current is already flowing through that circuit. Then when you no longer want the current to flow, you don't want to work, maybe you are busy doing something else, you don't want to run down your battery, then you remove the key. So we move on to the procedure. Now the first procedure says that set the power supply voltage to 5 volts. Now there is one thing I would like to always reiterate to students. For every heat and electricity experiment, there will be a circuit diagram. There will be a circuit diagram provided in your practical manual. And last semester, for our 107, we still had some students that refused to get the manual. If you see your results, and you meet the unexpected, it is not my fault. It is your fault, because I remember hammering on it that you need to get the manual. It is very important. This is an experimental course. So the manual is as important as the course. Now, it says set the power supply voltage to 5 volts. In the circuit diagram is there to guide you on how to set up your apparatus. After collecting your apparatus on how to set it up, the circuit diagram will be there to be your guide, as well as us as well. So the circuit diagram is there to guide you on how your setup is going to look like. So it says set the power supply voltage to 5 volts. So the power supply voltage, the power supply you'll be given, probably a battery of 5 volts, or you'll be given, okay, since we are talking about a variable power supply, there is a particular device that is that supplied voltage to us. So you can always control it. You can set it to particular voltage that you want it to be. So the procedure says that you set the power supply voltage to 5 volts. That's the first thing. The first power supply you'll be working with. So the first one you'll be supplying with is 5 volts. Then you close the switch. Remember I told you, by the time you close the switch, the current has started flowing and your circuit must work, as long as the switch is closed and your connections are correct. So if you remove the switch, it means you no longer want current to flow and it's no more working. So that switch is very important, and you must not just do anyhow with it, or else you will run down your power supply voltage, especially if you are being given a battery. So by the time you close the switch, the light will come on. Then you record whatever you have on your voltmeter and your ammeter. Remember I said it when I was telling you about the apparatus you'll be given. The voltmeter, you use it to record voltage. Ammeter readings is for current. So you record whatever your voltmeter or your ammeter reads. You record it down for the first one. Then you reduce the power supply voltage. The first one you set was 5 volts. So you can decide to set the second one to maybe 4.0 or 3.5. So you reduce your power supply volt. After reducing the power supply volt, then you record again your ammeter and your voltmeter reading. So you continue to reduce your power supply volt. That is why the topic says using a variable power supply. Using a variable power supply. You get it now? So you continue to reduce down your power supply. You continue to reduce down your power supply, and as you reduce, you record your voltmeter and your ammeter. So till you have 6 sets of readings. The first reading is for 5 volts. Then you have 5 other ones as you reduce your 5 volts. So after having that, you have your readings. So you'll be having your table. Draw a table with values P, R, and I. P, R, and I. The power supply, then your voltage and your current. P, I, and V. Remember I said that we will have gotten you get values for your P, which is a variable power supply. You will have recorded your voltage, the current, then you get your resistance. You can get resistance since we're having values for V and I, so you'll be able to get your R from Ohm's law. So this is a typical example of how the circuit diagrams look. The circuit diagram for this particular experiment look. Where you're having your V, that is the voltmeter. When you're having your A, that is the ammeter. That is the filament bulb under that your voltmeter, and this is a variable power supply. So this is just a simple circuit diagram. It might actually not look exactly like this, but this is how it's probably looks like. These are the major connections you need to do in the circuit diagram. So Continuation of the procedure, it says given the relationship I and R as P equals to A, small letter A, R raised power 4 plus B. Then when you linearize, remember we did linearizing in a first semester. By the time you linearize your P equals to A, R raised power 4 plus B, then you get your P. It means that your P will be what you plot on your y-axis. It means that your R raised power 4 will be on your x-axis depending on what you are being asked to do. Now in another instance, now you might be asked to do to plot P against R. If you are plotting P against R, it means your slope, what you'll be having for your slope will not be A, small letter A, R raised power 3, because you need to separate one R from that R raised power 4. So you now be having P equals to A, R raised power 3 dot R dot R. So your slope will not be A, R raised power 3, then the other R will be for your x-axis, plus B, which is your intercept. Now compare y equals to mx plus c with equation 1. Y equals to P, x equals to R. Plot the graph of P on y-axis and R on the x-axis. So I'm not so sure your graph, what you'll be asked to plot in the practical class, in the manual. I'm not so sure if if you are plotting P against R raised power 4 or you are plotting P against ordinary R. So whatever the case may be, if you are plotting P against R raised power 4, it means your slope will be equated to that A, then your intercept will be B. But if you are plotting A to R alone, it means your slope will be equated to A R raised power 3. So determine the gradient and intercept on the y-axis. From the graph, determine the values of A and B. So which means you have to plot your graph first before you can get the values for your A and B, before you can get your slope and your intercept. All these things, they all depend on your graph. Now I want to quickly talk about the graph. You see, in your exam, in physics 107 exam, for the one we did last semester, 2005, some of us, we I don't know, maybe it was examination tension or we're just confused. Some people, they do not know how to plot a straight line graph. Some people do not, they didn't even pick point. They didn't draw that line of it for me. They just drew a straight line for themselves, and after drawing that straight line, they just put their own point, at least that's already formed. You cannot tell me that if you're having 7 or 6 points and your line of it will now pick all the 6 points. It is not possible. No matter how perfect your graph might look, it is not possible for it to pick every point on the graph. At least 1 or 2 or even 3 will be left out, will not fall exactly on that line of it. So we have to be very careful. The person checking your work is not dumb. So when you are presenting your result, this is a typical example of how your table should look like. Remember, the first thing you have to have is the power supply, the variable power supply, and you have to start with 5 volts. So 5 volts, you can take 4, you can take 3, you can take 2, you can take it. Just make sure that you are reducing the 5 volts. Then you have your 5 volts. By the time you close your switch, then you check the voltage on the voltmeter, you check your ammeter for the current. From the values you're having for your V and I, you get your R, which is the resistance. After getting your resistance, you get your R raised to power 4. So you do that for the other variable power supplies that you make use of. You make sure you complete the table. I can bet it with you, some people do not know how to do simple calculations on their table. I can't imagine someone not being able to just divide the value given to you divided by 20 to get your capital letter T for period. Something that is as simple that you are saying. Someone was even telling me that, nah ma, you're not supposed to put it like that. You're supposed to allow us do it without you putting it. It's just like you telling us what to do already. And still, some people still do not get it. I told you, on this, when you are doing this type of thing, do not leave it in 2 decimal places. At least 3 decimal places, 3 or 4 decimal places. That is what I want. Some people still did 2 decimal places and they end up getting half mark. So if you are to get your resistance, your R is power 4 for me now, put them in 3 or 4 decimal places, not 2 decimal places. I can still accept your voltage and your current in 2 decimal places, but others, no, I won't. Okay, so the next one says sources of errors in the experiment. So in this particular experiment, what are the sources of error? What are those things that might hinder our experiment, that might cause error in our experiment? Experimental errors can occur due to variety of reasons. There are so many things that can cause error in our experiment. You know, from our physics 107 knowledge, we can have errors due to the equipment that we are using. Errors can come from it can be due to environment. There might be environmental, it might even be from our own human mistakes. So there are various ways that we can encounter errors in experiment, and these things can cause our experimental errors day in day out during experiment. The first one, we said it, that the 2 major types of errors are the systematic and the random errors. The ones that happens due to our instrument, the one that happens in our instrument because of our environment, the one that might affect us, that we might not even know how it happened, the fault the fault in the instrument itself. If you can remember very well, I told us that some of the instruments we have, or apparatus we have in the lab, are as old as the department itself. So there might be errors from this type of instrument or apparatus. So anytime we feel something is wrong with our readings or from our apparatus, please always signify and inform the appropriate quarter so that we can attend to it appropriately as at when due. Now, precautions. Before I go through the precautions for this particular class, let me quickly address something. If you are being given an alternative to practical, what alternative to practical means? Giving you questions, a practical questions, not outside the practical class, just like we used to do in our exam. For our exam, it's just like we are giving you questions on what we have already done in the practical lab during our physical class. So if you are trying to tell me the precautions, you are not, as at that particular moment you are writing the exam, the experiment has already been done. The experiment has been done. So it's like you are trying to report what has been done to me, or to the examiner. So whenever you are writing precaution, you write it in a reported format. Make it in past tense. Don't say the experiment, okay, the experiment was I ensured, that the correct thing to say is I ensured that parallax error was avoided. I ensured that my stopwatch, I ensured that I read my stopwatch accurately or appropriately. So I ensured is just like I did something in the past and I'm telling you what I did. So you use a reported speech. The fact that I'm not using a reported speech to tell you the precautions now, is because we have not done the experiment. I am just telling you the probable precautions you are going to be making use of when you are coming, when you come for the experiment. So by the time you have already performed the experiment and you are trying to report to me the precautions that you follow, you report it in a reported speech in the past tense, because you have already done it. I haven't done anything, I'm just teaching you how it will be. So that is why I'm not using that type of speech now. So the precaution says check that all components of the circuit are properly connected. So if you want to tell me, you want to report your own now after doing, say I ensured that I check all the components of the circuit and they are properly connected. Now me, the second one I said is that check that the connection wire is tightly connected to each device or component. So if you are to tell me after doing this experiment now, you tell me that I ensure that all the connecting wires are tightly connected to each of the devices or components. The last one I wrote is do not switch or touch any component with wet hand. I made sure that any of the components were not touched with wet hand. So you report in such manner, please. Thank you. Assignment. It says from Ohm's law, make I the subject of the equation, the subject of the formula, and substitute into equation 1. You remember that power dissipation equation I told you about? So this is what I want us to do. This particular assignment, you solve it into a paper. Remember that our Physics 107 WhatsApp group that we created last semester. You send it to that particular WhatsApp group. As soon as you listen to this, you do it and drop it. So you solve and derive those two other formulas that we derive from P equals VI using Ohm's law. You work them out and send to the WhatsApp group. Thank you very much and have a lovely day. Bye.